Okay, so today we'll discuss about assignment number 4, and from assignment number 4 there are A and B part. So in A part you have to implement the binary search for sorted array, and B part you can either implement DFS, that is depth first search algorithm, okay, or breadth first search algorithm, and that is either DFS, BFS, or BFS using the traversal of graph to reach target in shortest possible path. So you have options there for breadth first and the depth first search algorithm. So binary search is the compulsory, and one BFS and one DFS you can implement there using the OpenMP approach, if you see there. And objectives of this assignment will be to understand the parallel search algorithms. So you have to design parallel algorithm using a given serial version of a algorithm, if you see that. Then second part, that is you have to implement the BFS, DFS, and binary first search algorithm as per our requirement. But we'll take only binary search algorithm and DFS or BFS because we have options there. Then what will be the outcomes of this particular there? You should understand the parallel search algorithms and its implementation. If you see that. Am I audible now?
Yes, sir.
Hello?
Yes, sir. Yes, sir. You are audible.
Okay. And software requirements are C++ programming language. If you see that, and hardware the requirements, you can say the machine having the you can say the 64-bit operating system and a minimum 4 GB RAM, because this is the OpenMP application, and operating system like the Linux, Ubuntu, Fedora, and having the G++ compiler installed in that particular uh, machine, if you see that. And as far as theory is concerned, we'll see first binary search for sorted array, because you can design parallel binary search algorithm on a sorted array, if you see there. And you know binary search is uh, using the divide and conquer algorithmic strategy, if you see there. That is, every time it is dividing the given array into two sub array, that is the left sub array and right sub array. Recursively this is happening until the you will get the required element either in left sub array or the right sub array. This process will be recursive, if you see there. Then we'll directly and there you are using the low, that is the index of the 0th element, and high, that is the index of the you can say the nth element there. And you are finding the mid equal to low plus high divided by 2, if you see that. And every time you are dividing array into two sub array, left sub array and right sub array. That is the if element is less than that mid. Okay, so you have to find out the that element in a lower sub array. If it is greater than mid, then you need to search that element in upper or the right sub array, and that will be the recursive process. Okay, again you can subdivide the that is left sub array into two sub array, and right sub array into two sub array, that is in left sub array and right sub array recursively, if you see that, until you will get the that element that is to be searched in that respective you can say the subarray. So this is the recursive process. So we'll directly take it with the help of the example how it works, if you see there. So we have taken here total 10 elements having the index from 0 to 9. These are already in a sorted array, if you see that. Then we will see here that is the we want to search the element 31. Okay, if you see the following is our sorted array, and let us assume that we need to search the location of value 31 using binary search. Okay, determine half of the binary by using formula mid equal to low plus high, but here you can use low, value of low is 0. So you can use this formula also, mid equal to low plus high minus low divided by 2. That is the low is 0 plus high minus low means 9 minus 0, that is 9 by 2, that is 4.5. So you have to take the approximate value as a 4 there. So here it is 0 plus 9 minus 0 divided by 2 equal to 4. So 4 is the mid of a array. If you see that is mid of a original array in first you can say the step. If you see that, and you have to find the element that is the 31. If you see that, and your mid is 4 means element 27 is located at mid position, that is the fourth position there. So as 31 is greater than 27, then you need to find or search your element in a that is the right subarray there. If you see that, okay, now compare the value stored at location 4 with value being searched, that is 31. Find that the value at location 4 is 27, which not match. Yes, you initially have tried to match it with the mid, that is the key equal to mid. It is not match there. Then you need to search in a that is the upper or right subarray there. The value is greater than 27 and have a sorted array. So also know that the target value must be upper portion of array. Yeah, definitely it is at the right of that particular position, that is the mid. If you see that, then change our low to mid plus 1. Then you need to search that element in a that is the upper subarray or the right subarray. So you will change the value of mid from that is the low from 0 to mid plus 1. Okay, for the right side subarray, and find the new mid value again, that is the low equal to mid plus 1, then mid equal to low plus high minus low divided by 2. That is the low is, again we are considering their value of low is mid plus 1. So mid plus 1 there you know that is the 5. If you see that, and plus high is the 9 minus 5. If you see that is again 4. So 9 by 2. Our new mid is no, sorry, okay, here low is taken as a 0 again. 0 plus high is the 9. And minus it is something jumbling is there. Our new mid is 7. How it comes? Low is the uh, yes, new low is the we have taken 5. Yeah, plus high minus 0. If you see that is the high minus low means here in second case low is 0. So 5 plus 9 divided by 2, that is 14 by 2. It comes to the 7. Okay, so our new mid is 7. Now we compare the value stored at location 7 with our target value, that is the element to be searched, that is the 31. If you see that, the value stored at location 7 is not a match. So you are trying to match that is the key value that is to be searched with the new mid, that is the 7. That is at that location value is 35, but there will be no match. Okay, value to be searched is the less than that one. If you see that, so it is more than that we looking for. So the value must be in the lower part from the that particular location. If you see that, then calculate mid again. This time it is 5. If you see that, and if new mid is 5, in that case you will try to match that particular key with that particular mid, and there will be the match. If you see that, so finally you will get the element that is to be searched at the position 5, that is the 31. If you see that, and okay, so in this way you have to keep the searching the element using the parallel binary search algorithm also. Okay, but here you need to use the parallel construct. Okay, using the OpenMP approach, that is the you can use for recursive call or recursive part. We are using their section. Okay, if you see there, recursive parallel construct as a section you can use there. So there you can use the two sections or sections means more than one. So, and under that you can write a subsection, that is the one section for the recursive left subarray, okay, from each partition, and another section for the recursive that is the call for a right subarray, if you see that in each partition. That kind of construct you can design there for the parallel binary search algorithm. Okay, then we'll directly say that program also. We'll discuss that one also. Yeah, so you can implement binary search algorithm using the OpenMP construct. You need to use the header file #omp.h. This is important. Open multiprocessing. These libraries will be included in your program, and you are implementing this assignment using the C++. So using namespace study, you are declaring function in binary, int pointer, that is the pointer to array, then int low, then int high, and int key, that is the element to be searched. Then int mid also you are declaring, and initially mid equal to, that is you are defining this function here, int binary, int pointer a, that is the pointer to a array. Okay, array will contain the n elements. Okay, so you have to declare that array, enter the element of that array, n element, then it will have the low index and the high index in that array, and key will be the element to be searched in that sorted array. Remember this one. So int mid, you have declared the mid equal to low plus high divided by 2. In this way you can find out the mid of the given sorted array. Then you can declare the uh, required variables, that is the for each subpartition. If you see there will be the new low and new high and new mid also possible. That's why int low 1, low 2, high 1, high 2, mid 1, mid 2, found equal to 0. Okay, that kind of you can see the flag like variable you can consider there. Low is equal to -1. So initially location will be equal to -1. Okay, so it will start searching from the -1, that is the before the 0th location, if you see that. Then you are using the parallel construct #pragma omp parallel sections, just discussed. So #pragma omp parallel sections means from this statement onward, your parallel execution will start. That is the master thread will call the that is the fork system call, and that is the collection of threads will be created there. That is at least one thread per core. If you see that, if it is the your machine having the 4 core, then 4 number of threads will be created. If it is having the you can say the 8 core, 8 number of threads will be created in that case. Okay, then again you are using the means from this line onward your parallel execution will start. So till that line the execution was serial execution, if you see that. So then whenever #pragma omp parallel sections this statement encountered, your parallel execution will start there, if you see that. Then you are using the again the #pragma omp section. Okay, as discussed earlier, this is for the left sub array or sub partition, and another one you can use for the right sub array or the right sub partition #pragma omp section. Okay, so this is also possible there. Then for left sub partition, if you see there, low 1 equal to low, because we have already found mid equal to low plus high divided by 2. So low 1 equal to low, high 1 equal to mid for the left sub array. Okay, after performing the partition. Okay, so then while low 1 less than high 1 less than or equal to high 1, and if key greater than or equal to a long means and key less than or equal to a of high 1. This condition is false. If this condition is false, then low 1 equal to low 1 plus high 1, and you need to continue this process if you see there. Okay, for the left sub array. Okay, year 1 means this is for the left sub array, and then you can find out the new mid also. Mid 1 equal to low 1 plus high 1 divided by 2. If key equal to a of mid 1, found equal to 1, you return the found equal to 1. Initially it was set to 0. Now you have to change its value, found equal to 1, and LOC equal to, that is the location is equal to mid 1 itself, because that element found at location mid 1. If you say that, then you need to increment the value of low 1. Low 1 equal to high 1 plus 1 in this case. Okay, and else if key greater than a of mid 1, and if the element to be searched, that is the key, is greater than a of mid 1 location element. If you say that, in that case you need to search it into the you can say the right sub array. If you see that low 1 equal to mid 1 plus 1, in that case, if you see that. Else if key less than a of mid 1, and high 1 equal to mid 1 minus 1. Okay, otherwise your element will be that is the in a left sub array, if you see that, and high 1 equal to mid 1 minus 1 there. So this is process for that is the left sub array, and similarly you can perform for the right sub array also. That is the low 2 equal to hash pragma OMP section, low 2 equal to mid plus 1, high 2 equal to high, and while low 2 is less than or equal to high 2, and if this condition is not true, that is the key greater than or equal to a of low 2, and key less than or equal to a of high 2. So low 2 equal to low 2 plus high 2. We need to continue this process. That is the for the right sub array. Here 2 means for the right sub array, and mid 2 equal to low 2 plus high 2 divided by 2. And if key equal to a of mid 2, then found equal to 1 again, like the left sub array, and LOC equal to mid 2, and low 2 will become equal to high 2 plus 1 there. Else if key greater than a of mid 2, then low 2 equal to mid 2 plus 1 again, and else if key less than a of mid 2, high 2 equal to mid 2 minus 1. In this way it will work, and finally you need to return the location of the element that is found, if you see there, LOC. So this is the in this way you can define the parallel construct for the binary search algorithm, which we have already discussed with the help of one example. And you can define main function also here, int main, for declaring array and array elements. You have to enter here int pointer a, I and key LOC equal to -1. Say out, enter total number of elements, c in n, a equal to new int of n. Then c out, enter the elements for I equal to 0, I less than n, I plus plus, c in a of I. And then say out, enter key to find, c in key. If you see that, so you have to enter array elements, okay, n number of elements, and then enter the key, that is the element to be searched. If you see then you can make the call to the binary search function there, LOC equal to binary of a comma 0 comma n minus 1 comma key. So a is the array. These are the, you can say, the parameters you are passing. Okay, array a, 0 is the low, n minus 1 is the high, k is the element to be searched. Okay, that will be the call to the that function int binary. And finally, if LOC equal to -1, see out key not found. Okay, so after searching, that is the all elements of the left sub array and right sub array. If element if you are not found that particular element, in that case, if LOC equal to -1, then you need to print their message, that is the key not found. If you see there, else key found at position LOC plus 1. Okay, LOC plus 1, why? Because we have set LOC equal to -1. If it is at location 0, then LOC that is the 0, you can say the, yeah, that is the LOC is set to the -1, if you see that. And if it is at location 0, that is the -1 + 1, that will become 0. If you see that, that's why LOC +1 you need to use there, and finally return 0. And how to compile this program, you know already. That is using the OpenMP G++ binary search.cpp --f OpenMP. If there are no errors, /a.out, enter total number of elements. I have entered 6. Enter elements 5 to 67, 23, then 1, 8, and 12. If you see there, I have entered 7 element, I think. Okay, then enter key to find 23, for example. Then key found at position 2. If you see there, because I have considered 2, 67, and 23. 2 is the you can show the 0th element there, and 67 first, and 23 is second element. So in that case, key found at position 2. If you see there, so in this way, binary search algorithm will work there. So today, I think we will see only this assignment, and we will stop here. If you have any query, you can discuss.